We have a very interesting question here, but we need to visualize what they are talking about. So let's get going. Given to you is P is a plane which is given like this. Let's draw it. So let's closely look at this equation of the plane given. What information do you extract from here? Do you know that root 3, 2 and 3, which are coefficients here, they give you the direction ratios of the normal to the plane. Now if I try to convert this into direction cosine, how do we do that? We divide this vector by magnitude of the same. So what is magnitude of this vector? Under root 3 square, that's 3, and then 4 plus 9. That's root 16, that's 4. So we are dividing this complete equation by 4. So now what happens? These have become now direction cosines of the normal. And what is this? That's the interesting thing which you need to know. This is 4. What is this 4 telling you? The plane from the origin. That is what the 4 is. That means if this is my origin and this is P, then my OP is 4. Let's read more. S is a set which is collection of all such vectors such that this happens. What does it mean? It means it's a unit vector. And what else? The distance of the same vector from the plane is 7 by 2. That means if I consider some vector u which lies in that set, that means distance of that from the origin is 1, and distance of the same vector from the given plane, that is how much? 7 by 2. Let u, v, w be three distinct vectors in x. Okay, so u we have already here. Let's draw two more. Okay, let's say v is here. So v has the same property, that distance is 1 from the origin, and from this plane the distance of v is again 7 by 2. Okay, similarly let's have another vector w here, somewhere here maybe. Okay, again the same, distance from the origin is 1 and from that plane is. Once you have drawn the three things, okay, don't you think that all these three vectors, if I try to join them and make a plane, okay, because all the 3 points are at same distance from this given plane, right? Don't you think that they are going to lie in a plane which is parallel to the given plane? Yes. Okay, so these two are parallel planes. Okay, next, get going. Modulus of u minus v. What is that? Modulus of u minus v. Distance between u vector and v vector. That means this h they are talking about. Okay, v minus w, that means this h they are talking about, and similarly what, this h, they are all equal. Let's assume something. Let's say that these are all equal to a. So this is a, this is a, this is a. Okay, now what are they asking us? V be the volume of the parallelepiped determined by the three vectors. Great. Okay, so you do know, right? How do you find volume of the parallelepiped defined by the three vectors? Yeah, you take the scalar triple product. So what's my problem now? I don't know what is UVW, right? You have to find out what is UVW. Now let's look at what information you have. There are two informations. Okay, distance of the given plane, okay, from the origin, that is 4, and distance of this plane which you have just now constructed using the triangle from the given plane, that is how much? That is 7 by 2. Do you think I can exploit the distance thing if I know the distance of this triangle plane from the origin, right? If I do know that, let's try to find out. Okay, do you think, first of all, that the center of the triangle, that is the centroid, okay, it is just, origin is just below the centroid, right? Because you see, distance of all the vertices is the same, 1, 1 and 1. So origin is lying just below the centroid. Okay, now if I need to know, so that's my whole question, right? I need to know what is my OG. Okay, if I get my OG, I can use that distance thing. Okay, what is distance of this plane from the origin? Okay, so for that, what do I know? I need to find out this distance, right? Because I do know this is 1. Okay, let's name it A. Okay, let's say this is B, this is C. So I need to know what is my AG. Okay, let's find out. Not difficult. Okay, because you have a equilateral triangle. This is A, this is B, and this is C. And you drop a perpendicular. This is D. Okay, it doesn't look equilateral, but it is. Okay, uh, so what is AD? A by 2. Here you have a centroid G, and you need to find out what is AG. Okay, not a problem. What do you do? First find BD. How much is BD? This is 60, right? A sine 60. Okay, so A root 3 by 2. How much is your now GD? G is the centroid, right? So one third of that. So GD is one third of BD. Okay, root 3 by 2. That's A upon how much? 2 root 3. Okay, now can you get what is your AG? Yes, use your Pythagoras. Okay, AG square would be this is square, that is A square by 4 plus this is square, okay, that is this. So A square by 12. Okay, how much do you get? Yeah, 4A square by 12, that is A square by 3. Okay, so AG is what? A by root 3. Okay, you got your AG to be A over root 3. Now, can you get your OG? Pakka? Under root, OG is under root of 1 square minus AG square. Okay, so 1 minus how much is AG square? A square by 3. Now, let's do the magic thing. Okay, distance thing. So, OG plus GP. Okay, that's equal to how much? OP. See, OG plus GP, okay, this whole thing, that is the complete distance, that's 4, that's 4. Okay, so let's write the values which we got. Okay, 1 minus A square by 3 plus GP is what? Distance of this plane, the triangle plane, from the given plane, that's 7 by 2 they have given, and this is 4. Okay, now solve it for A. How much do you get? Okay, so you get 1 minus A square by 3 is equal to how much? This is 1 by 4. Okay, so you get A square to be 9 by 4. So A is 3 by 2. Okay, you got the value of A. What did you end up in getting? You end up in getting a distance between U and V. Okay, so this you what got is 3 by 2. Okay, all of them are 3 by 2. This is 3 by 2. This is 3 by 2. Okay, so still we don't have, right, U, V and W. What more information can we extract from there? Okay, let's look at that. So if I know that information, that modulus of U minus V is 3 by 2. Okay, so is everyone. Okay, U, V minus W. But let's look at one. If you do a square, you understood what we are trying to get. Okay, what do you get? Modulus of U square, modulus of V square minus 2U dot V. Okay, that's equal to 9 by 4. So what is U dot 2U dot V? This is 1. Okay, this is 1, this is 1. 2 minus 9 by 4, that would be minus 1 by 4. Okay, so U dot V is negative 1 over 8. Okay, so what do you end up in getting? Everyone. Okay, the dot product. Okay, U dot V is same as V dot W is same as W dot U, and everyone is how much? Minus 1 by 8. Why did we do that? Because I know the alternative formula. Okay, that V square, if I do, this is equal to the determinant I'm going to write. You know that this is the determinant. Okay, V square is equal to this determinant. Okay, that is the alternative formula. Now we have to just insert the values. Okay, because you know U dot U, that is modulus of U square, that's 1. V dot V is also you know, and W dot W also you know, so 1 1 1 diagonals you know, and rest of them are what? This negative 1 by 8. So just fill it up. Now solving the determinant should not be a problem. You can always take the fractions outside. 1 by 8 from every row, you can just take it out and then work with integers. You end up in getting 9 into 54 upon 8 cube if you do so. Okay, now V is under root of that, 9 root 3 by 16. Just take the under root of this whole stuff. Okay, now what are they asking? 8, 80 over root 3 of V. Okay, how much is that? 80 over root 3, and V value we got to be this. Okay, so this is how much? This is 5. You end up in getting a 45. So little visualization and the volume formula should be known to us. Okay, I will see you with another question soon. Bye bye.